Greetings, Mr. Lee here. Let's practice some end behavior, okay? So first of all, this is kind of the language of end behavior. Hopefully this looks familiar. You're thinking, what is your y value doing when your x value approaches the end of your graph, right? So if you're thinking the ends of your graph in terms of the x values, you're looking at positive infinity and negative infinity, right? So what happens as x keeps going to the very right, and what happens as x goes to the very left of your graph, okay? So this is the language. As x approaches infinity, all the way to the right, what is your function value doing? What's your y value doing, right? Remember that f of x, same as your y value, output value. And then similarly, as x approaches the very left of your graph, negative infinity, what's your y value doing there? Okay, so here's how you read on the graph. This is asking what's the end behavior as x approaches positive infinity, okay? So I'm just gonna look at the very right of the graph. As x keeps going towards the right, you guys see this arrow, it keeps going towards the right, it's going to eventually get closer and closer and closer to this asymptote, okay? So we have an asymptote here at a y value of 1. If you guys remember the equation of a horizontal line, it's going to be y equals some number. In this case, it's y equals 1. So then I'm going to pick the function value equal to 1. That's what your y value will get closer and closer to. That's what it will approach as your x value keeps going towards the right. Okay, let's just talk about the negative infinity. Okay, this is your answer already. If your x value was approaching negative infinity, we're going to look at the very left. It's going to keep going left, and same thing. There's the same asymptote here at y equals 1. We would actually have the same answer in this case. Okay, end behavior as x approaches negative infinity. Okay, so negative infinity, we're looking at this kind of second option as x approaches to the left. So I'm going to pick the graph anywhere, go all the way to the left. You're assuming this goes on forever to the left and forever down. Okay, forever left, forever down. So as x keeps going towards the left, my y value, or my function value, is going to keep going down. So as x approaches negative infinity, as it keeps going left, my y value will approach negative infinity as well as it keeps going down. Okay? So red's our answer. Again, let's talk about both ends, so you guys have a better idea. If we're asked end behavior as x approaches positive infinity, as the graph keeps going to the right, that means the y values are going to keep going up. So this one would be positive infinity, right? But then we were asked for negative infinity. So then graph keeps going down. We're going to choose the red option. All right, let's do one more. All right, this one we have an asymptote. That's important to note. This is probably like an exponential or logarithmic function. No, it has to be an exponential function. So then end behavior as x approaches infinity. Okay, so let's talk about both, but we'll answer the question first. We're going to look as the graph approaches infinity. So the x values are going to keep going to the right. It's going to keep getting closer, closer, and closer to this asymptote, which is at a y value of 2. Okay, you guys can click the graph if you need to look closer. But it is going to be a y value of 2. The equation of that line is y equals 2. You can also think of it as f of x equals 2. Okay, so that's the answer. If we were asked end behavior as x approaches negative infinity, as x keeps going to the left, what's happening? I don't have any horizontal asymptote down here. The y values is going to keep going down, so we would say negative infinity. Okay, but let's answer the question as we originally talked about it. X approaches positive infinity, gets closer and closer to the asymptote, y equals 2. All right, there you go.